In this video, I will be walking you through important Git terminologies which you will be using very frequently. Understanding these terminologies will also help you understand how Git works. We shall begin with understanding what a master branch is. Master is a default branch or a working copy which is created by Git when you create a repository. It has a working directory, a staging area, and also maintains the commit history. By convention, master refers to the main branch and is equivalent to trunk if you have used SVN before. By convention, master is considered as the source of truth and will be integrated with CI tools like Jenkins. Every repository has a master branch of its own and generally points to the master branch of the remote repository. This block diagram shows the logical view of the master branch after each commit. Now we shall see what a branch is. A branch is a lightweight working copy for parallel line of development. It has its own staging area, a working directory, and maintains the project history. Normally, branches are created to work in isolation without impacting the master branch for feature development, and later the changes from the working branch is merged back to the master branch once the feature is complete. This block diagram here shows the logical view of the branch creation and merging back to the master branch. Now we shall see what a head is. A head is just a logical pointer to the last commit of the working branch. By convention, head is written in capital letters. There will be only one head per repository, and when we switch between branches, the head will be pointing to the latest commit of the selected branch. One more important point to note here is when we perform a commit, the head will also move to point to the latest commit. This block diagram here shows how a head looks like. As we can see, the head is pointing to hedge, which is the last commit of the working branch. Now that we have seen what a head is, we shall look at the remote. A remote is just another Git repository on the network outside the local machine. There can be more than one remote repository pointing from the local repo and is very common when working on a project. It's difficult to manage remote repositories with the complete path, and hence we can refer to the remotes with the logical short name. We can even add, rename, and delete the remotes. The block diagram here shows the logical representation of a local repo having reference to more than one remote repository. Origin. As I just mentioned that Git associates remote repository with names, origin just happens to be the logical name set for the default repository by convention. This way of addressing the default repo with origin will be very useful to point to the default repo when running Git commands instead of the entire repo URL, and it's always easier to remember the logical name of the repo than remembering the complete URL. This diagram shows a local repo to have been configured with two remotes, one being named as remote 2 and the default being origin. Clone. Clone is a term used to get a copy of the existing repository from a remote repo, and we clone the repo using the clone command. Remember that cloning a remote repository is done only once and is in the beginning. After we have cloned the repo, we will then only get the updates from the remote afterwards. If you have worked with SVN, clone is similar to checkout with SVN, with only the difference being that clone will get the complete repo, whereas checkout will only fetch the working copy. This diagram shows running the git clone command to replicate the remote repo on the local machine. Push is a commonly used term and also the command to push the changes from the local repo to the remote. Push can be performed only once the changes are committed to the local repository. Issuing a push command will sync the changes committed to the local repo with the remote. Note that if at the time of pushing the local changes, the local repo is not in sync with the remote, the push command will fail. The local repo should then be updated with the remote before attempting to push the changes successfully. And this is the logical diagram for the git push command. Now that we have seen push, we shall see the pull command, which is the exact opposite of the push. The pull command is used to get the updates from the remote repository to the local repo and sync the changes from the remote to the local. The pull command takes the latest code from the remote repo and automatically merges the changes with the local repository. Next, we shall see the cousin of the pull command, which is the fetch command. Fetch is similar to the pull command except for the reason that it does not merge the changes from the remote with the local repo. The merging should be done explicitly unlike the pull command, and hence we can safely run the fetch command any number of times without impacting our development. However, we need to ensure that we need to merge the changes before we push the changes back to the remote. Lastly, we have two terms which are used very commonly, which are upstream and downstream repo. Since Git is a distributed version control, there cannot be an absolute upstream repo and a downstream repo. Instead, in Git, repos are always relative to each other. When data flows from repo A to repo A is considered to the upstream repo and repo B is termed as the downstream repo. Repo B will pull the data from repo A and then push back to the repo A. Now that we have understood the terminology, it will be easier to understand the concepts and correlate when we run the git commands.